The degree that I want to study is the biomedical engineer because it's a mixture of two things I like, the engineer and the medicine, and because it's really interesting for me how to apply the technology to support the health areas, and because with this you can save more lives. An example where you can apply integral calculus in this career is in chemotaxis. This is a process in which bacteria cells find food through glucose in response to leukocytes that are responsible for stimulating the immune system, which is in charge of defending the body. The normal concentration of leukocytes in blood is between 1,300 and 4,000 cells over cubic millimeter. When a result is greater than 1,000 cells over cubic millimeter, it will be a positive test for cancer cells. To know the amount of chemotaxis in the blood, centrifugation is carried out, which separates the substances from the blood, and this shows if there are cancer cells. To show if the patient has a diagnosis of cancer can also be calculated by integral defined by the substitution method. In our example, we can saw that we have a limit into 0 to 1, and our function is 4x over x2 squared plus 1 dx. Our u is going to be x2 squared plus 1, and our du is going to be 2x dx. To integrate this, we need to use the integration rules, because if we pass our u up, we are going to have x2 squared plus 1 to the minus 1. When we integrate, we add 1, so minus 1 plus 1 is going to be 0. So this is going to be cancelled, and this isn't the way to integrate this function. So we need to use the integration rules of du over u, that is equal to ln u plus c. Because our du is 2x and we originally had 4x, we need to take out a 2 because it's what we need to complete the value we had. Using the integral rule of du over u, that it's equal to ln of u plus c, we only put out the 2, we put ln, and we put the value of u, that it's x2 squared plus 1 plus c, and our limits, that it's 1 to 0. And this is our integral function. Now we only need to substitute our values 1 and 0 in the integrate function. It's like when we take the area between a graph and the x-axis. We only need to have the integrate function with the value of the highest limit and minus the lowest limit, as you can see in this graph. So our result is going to be 1.386 thousand cells per cubic millimeter. This indicates that the patient has no abnormalities in the blood. And this is because it is in the normal range of leukocytes in the blood.